Hi guys, so today we're gonna start talking about how to do examples 17 and 18. So let's start with example 17. Example 17 asks, an S wave arrived at a seismic station 6,200 kilometers away at 4 hours 48 minutes and 0 seconds. What time did the first P wave arrive at this station? So let's talk about the chronological order of how things are happening. First, the earthquake happens. Then the earthquake releases a P wave that arrives at my seismic station because it's the fastest wave. And then my earthquake releases an S wave, that's the slower wave, S for slower, and that reaches my seismic station last. So if I know when my S wave arrived, at my seismic station, which is this time and this distance that it traveled, I know that my P wave must have arrived at my station before the S wave because the P wave is faster. So to figure out when the P wave arrived, I can use my distance and my time to find and use my scrap paper on my reference table to find the time difference between my P and S wave at this distance, and then I can subtract from this time that my S wave arrived here to figure out when my P wave arrived because my P wave arrived at the station before the S wave. So here's how you would do it. An S wave arrived at the seismic station 6,200 kilometers away. So use your scrap paper to align it at 6,200. That's the distance that's given to me. And I'm going to make a line at the P wave and make a line at the S wave where they intersect with my scrap paper. Now, to find out the time difference between my P and S wave at this distance, I take my scrap paper to my y axis and align it with 0. And I see that the time difference of arrival between the P and S wave when they came to the seismic station is 7 minutes and 40 seconds. So I know when my S wave arrived, which is 4 hours, 48 minutes, and 0 seconds. My P wave must have arrived 7 minutes and 40 seconds before the S wave arrived. So that's why I'm taking the S wave arrival time and I'm subtracting the time difference that I found, which is 0 hours, 7 minutes, and 40 seconds. The answer that gives me is 4 hours, 40 minutes, 20 seconds. Here's how I did the calculations. So 4 hours, 48 minutes, and 0 seconds minus 0 hours, 7 minutes, and 40 seconds. The first step is notice that I can't really subtract 40 from 0. I have to take away from my minutes. So I'm going to cross the 48 and turn that into a 47. And now I can add 60 to my 0 because 1 minute is 60 seconds. And this is what I end up with 4 hours, 47 minutes, and 60 seconds minus 0 hours, 7 minutes, and 40 seconds. That's how my time difference is 4 hours, 40 minutes, and 20 seconds. That's my answer. So go ahead and pause this video and try example 18. Okay, so for example 18, I'm asked an S wave arrived at a seismic station 1,400 kilometers away at 9 hours 20 minutes and 40 seconds. What time did the first P wave arrive at the station? Once again, all I have to do is use my scrap tape paper to find the time difference of arrival for the P and S wave, and then by using this distance, and then I can subtract from the S wave arrival time with the time difference that I found to find the P wave arrival time because the P wave must have arrived at the station before the S wave. So my distance is 1,400. Here's 1,400. I'm going to align my scrap paper and mark a line at P and mark a line at the S wave where they intersect with my scrap paper. I'm going to take my scrap paper to my y axis and align one of my lines with 0. I see that the time difference of when my P wave and my S wave arrived at the station is 2 minutes and 20 seconds. So this is my S wave arrival time. I'm going to subtract 2 minutes and 20 seconds because I know that my P wave must have arrived at the station 2 minutes and 20 seconds before the S wave. So 9 hours, 20 minutes, and 40 seconds minus 0 hours, 2 minutes, and 20 seconds gives me 9 hours, 18 minutes, and 20 seconds. That's it for this video.